Hello everyone, today I'll give you a presentation for my final project. My topic is channel estimation for wireless OFDM systems. Or signal frequency diversion multiplexing or OFDM has been used widely in modern wireless communication due to its high bandwidth efficiency and robustness against frequency selective. OFDM has been used in applications such as DSL, wireless networks, and 4G mobile communications. Just as it says in its name, OFDM is a special case of FDM. As analogy, FDM's channel is like water flow out of a faucet, where OFDM is like a shower. In faucet, all water comes in one big stream and cannot be subdivided. Well, shower is made up of a lot of little streams. Another analogy is FDM is like all cargo on one truck, while for OFDM it has more than one truck. These two methods carry the same amount of data, but in case of accident, only one force will be suffered. So we can see the advantage of OFDM over FDM is that it can reduce interference by subcarriers and improve bandwidth efficiency. In OFDM, all subchannels are all signal. It's very important because if the channel are not all signal, it may lead to leakage interference from adjacent subchannels. So the guard band will be needed between adjacent frequency band and will result in extra overhead and lower throughput. The orthogonality allows simultaneous transmission on a lot of subcarriers in a tight frequency space without interference from each other. Well, for OFDM, there are many advantages. However, there are some disadvantages of OFDM should need to be overcome in future work. For example, high peak-to-average power (PAPR), byte error rate, and so on. Now let's look at OFDM diagram. Binary data was modulated by QPSK or QAM, and then signal experienced S2P conversion. S2P means serial to parallel. And then IFFT allowed signal translate from frequency domain to time domain. And then CP or guard interval was inserted to avoid possible ISI intersymbol interference, which is an unwanted phenomenon. It's a kind of distortion caused by interference between symbols and may lead error in decision devices. Then the signal experience P2S conversion, and then they were transmitted through a channel which is subject to adaptive white Gaussian noise, and then S2P conversion and remove CP. FFT allows signal translated from frequency domain from time domain to frequency domain, and then P2S conversion and demodulated. This is the whole process. This is the system architecture, and each function shows how each process works. For channel estimation, it is a tough task in wireless systems. Actually, OFDM has been viewed as 2D signal. 2D means refer to time and frequency. However, 2D is too complex to use in practice, so usually we use 1D to do channel estimation. There are two types of 1D channel estimation. One is called block-type pilot arrangement. The other is curve-type pilot arrangement. In block-type pilot arrangement, pilots are inserted periodically in time domain, and pilots are inserted in all subqueries of pilot symbol in a specific period. And because the training block contains all pilots, channel interpolation in frequency domain is not required, so it is relatively insensitive to frequency selective. In curve-time pilot arrangements, only some subqueries contain a pilot signal, but it is sensitive to frequency selective. For channel estimation, the pilot signals, which is represented by matrix X, received signal, which is represented by matrix Y, are given, and we need to estimate the channel condition, the little h, and this function can help us to solve this problem. There are two types estimators which are based on LS, least square, and MMSE, minimum mean square error. There are two functions that show the relationship of the two estimators. From the two functions, we can see that MMSE is more complex than LS estimator, and each MMSE is less than HLS. So we can predict that the performance of MMSE is better than LS. Now let's look at the channel estimation performance. We use mean square error MSE to evaluate the performance of two estimators. And there are four figures to show the performance of two estimators at different channel lengths 5, 10, 20, 40. And from the figure, we can see that at a certain ES over MO, the MSE of LS estimator is larger than the MSE of MMSE estimator. ES means simple energy over noise ratio. And the four figures have the same trend. So we can draw the conclusions. Firstly, LS estimator has low computation order but suffers from high mean square error. Secondly, MMSE estimator has high computation order but has low mean square error. And as the channel length increase, both LS estimator and MMSE estimator have higher mean square error. Related work and improvement. Though much effort has been paid to design channel estimation for OFDM systems both in theory and practice, pilot arrangement, and the complexity of using algorithms, solid mathematical proof of channel estimation. But what I did is give a direct view of relationship between the channel mean square error and the symbol energy to noise ratio. I also analysis the effect of channel length to channel estimator. Now, let me show you my MATLAB project. This is the parameters of my program. And there will be a figure to show two estimators at channel length at 5. Okay. And here's the reference list. and thank you for your attention.